In this video, we'll be learning the characteristics of quadratic functions and how to identify them when given in a graph or an equation. Here the quadratic function f of x equals ax squared plus bx plus c is shown. In this function, you know it's quadratic because it has the x squared. Now, several things you can tell just by reading this equation are y-intercept and whether your graph is going to be facing upward or downward. So your c is always going to be your y-intercept. In other words, your constant, or the number that's not attached to an x or a variable, will be your y-intercept. And then your a, the number in front of x squared, tells you your direction of opening. So if your a is a positive number greater than 0, then your graph will be facing upwards. If your a is a negative number, in other words, a is less than 0, then your graph will be facing downwards. Try to think of upwards like a regular U, so it's up. Downwards would be a flip U, so down. And then you have a vertex with quadratic functions. Your vertex is always that midpoint. So if your vertex is on the bottom of the graph, then it's a minimum because it's a low point. If your vertex is on the top of the graph, then it's a maximum because it's a high point. So again, the number in front of x squared, if it's positive, it tells you it's facing up. If it's negative, it tells you it's facing down. Some other key features besides your vertex are your axis of symmetry. So that line that cuts through the middle of your graph is called an axis of symmetry. Your x-intercepts, where the graph crosses the x-axis. For parabolas or quadratic functions, they can have up to 2 x-intercepts. And another name for x-intercepts that we're going to be using a lot in this chapter is zeros. The reason they're called zeros is because on the x-axis, y is equal to 0. The name of this graph, I mentioned it, but again, the U-shaped graphs are called parabola. So the graphs are called parabolas if they look like a U. Here we're going to practice identifying the features just by looking at a graph. So if we start with our y-intercept, we would look at where the graph intersects the y-axis. Here that's happening at about 8. So that would be our y-intercept. Your vertex is always a point. It's the midpoint of the graph. So it would be down here. So this would be our vertex. And right now it's at -3, -1. Always write your vertex as a point. Your axis of symmetry is the line that cuts through the middle of the graph. So I'm going to go ahead and draw that in here. This is my axis of symmetry. Since it's a line, it has an equation. Here you'll notice it crosses through -3 on the x. So it's x equals -3. Remember, axis has x, so you always have to write x equals. This is a regular U, so it looks like a regular U, so the direction of opening is upward. Remember, zeros mean x-intercepts. This one has 2. One of them is at -4. The other one's at -2. To tell if it has a maximum or minimum, you look at your graph. If the vertex is a high point, it's a max. If it's a minimum, it's a low. So here the vertex is a low point, making it a minimum. And you also want to give the value. Well, your min tells you how high or low something is, so you use the y. So we use the y, that's at -1. Domain, we learned previously. For domain, you look left to right. And it tells you your x's. So left to right. And you look at your x values. So on the left here, this one's going to keep going left. And on the right, it's going to keep going right because it doesn't have endpoints. So it's going to keep going left and right. If it keeps going left and right, that means your domain, which tells you the x's that your graph can have, is going to include all numbers. So our domain here would be all real numbers. For range, you think of y and you go bottom to top. So up and down. If you look at the bottom here, our bottom was at -1. But if you look at the top, it's going to keep going up. So it goes up from -1. In other words, all the y's that are on this graph are numbers that are higher than -1. If you were to pick any point, it would either have a -1 or a number higher than that for the y value. So for our range, we're going to write down y. And because our graph's going up, we're going to use greater than or equal to -1. So greater than or equal to is because it's going up. If it were going down, like a flip view, then it would be less than or equal to. So for example, here, we're not going to do everything. Let's just focus on domain and range and max or min. So we're doing max or min. Here it has a high point. So it has a max, and you would say the value, so that's at 3. If we were doing domain, this one's going to keep going left, and it's going to keep going right. It doesn't end from left to right. So the domain would be all real numbers. And if we're doing range, we would look bottom to top. So on the bottom here, you notice it's going to keep going down. On the top, it goes up to 3. So our range is y's that are going down from 3. So down would be less than or equal to 3. So y less than or equal to 3. And that's because this one's going down. A formula that you're going to be using a lot